After a 7-month journey through the cold, dark void of space, NASA's Mars rover was just hours away from a nail-biting landing. The stakes were higher than ever before. This wasn't just another mission. It was a bold gamble, a daring attempt to uncover the secrets of the Red Planet. And when NASA successfully landed its Perseverance rover on Mars, the world held its breath. The mission? To search for signs of life. But what it found would leave NASA scientists in shock and rewrite everything we thought we knew about Mars. NASA's Perseverance rover wasn't just another robotic explorer. It was a high-stakes bet, a mission that pushed the boundaries of human ingenuity. The landing itself was a feat of engineering brilliance. Scientists at NASA's Jet Propulsion Laboratory ditched traditional methods and went all in with a never-before-tested sky crane system. Picture this: a hovering platform, jets firing like a tiny spaceship, gently lowering a massive rover onto the Martian surface with cables. The risks were sky-high, but against all odds, Perseverance touched down safely in Jezero Crater, rewriting space history. And that was just the beginning. Jezero Crater wasn't just any dusty pit on Mars. It was a window into the planet's deep past, a time capsule hiding secrets in its layers of rock. Billions of years ago, this crater was a lake, filled with water that could have supported life. Perseverance's mission was clear: explore, analyze, and uncover the truth. The rover got straight to work, snapping photos, checking instruments, and exploring its surroundings. One of its most impressive tools? A laser-blasting gadget called ChemCam. This device could zap rocks and read the light that bounced off, revealing their composition. The first test was on a rock named Coronation, and the laser was so hot it could outshine the sun's surface for a split second. But Perseverance wasn't just about shooting lasers. It drilled into rocks, scooped up soil, and even baked samples in its onboard oven. And then came the real shock. It detected methane. On Earth, methane is often linked to life. Microbes deep underground, cows doing their thing, even decaying plants. But on Mars, no one knows for sure. Could it be from buried life forms long gone? Or is it just the planet's chemistry playing tricks? Either way, it was a mystery that made scientists rethink everything they thought they knew. Conceivably, if life exists or existed on Mars, evidence of life could be found, or is best preserved, in the subsurface, away from present-day harsh surface conditions. Present-day life on Mars, or its biosignatures, could occur kilometers below the surface, or in subsurface geothermal hotspots, or it could occur a few meters below the surface. The permafrost layer on Mars is only a couple of centimeters below the surface, and salty brines can be liquid a few centimeters below that, but not far down. Water is close to its boiling point even at the deepest points in the Hellas Basin, and so cannot remain liquid for long on the surface of Mars in its present state, except after a sudden release of underground water. So far, NASA has pursued a follow-the-water strategy on Mars and has not searched for biosignatures for life there directly since the Viking missions. The consensus by astrobiologists is that it may be necessary to access the Martian subsurface to find currently habitable environments. Cosmic radiation. In 1965, the Mariner 4 probe discovered that Mars had no global magnetic field that would protect the planet from potentially life-threatening cosmic radiation and solar radiation. Observations made in the late 1990s by the Mars Global Surveyor confirmed this discovery. Scientists speculate that the lack of magnetic shielding helped the solar wind blow away much of Mars's atmosphere over the course of several billion years. As a result, the planet has been vulnerable to radiation from space for about 4 billion years. Recent in situ data from Curiosity rover indicates that ionizing radiation from galactic cosmic rays, GCR, and solar particle events, SPE, may not be a limiting factor in habitability assessments for present-day surface life on Mars. The level of 76 milligrays per year measured by Curiosity is similar to levels inside the ISS. As Perseverance roamed the Martian surface, it kept finding more proof that Mars once had lakes and rivers. Imagine a planet where water once flowed freely, filling ancient valleys and leaving behind clues in the rocks. Billions of years ago, Mars might have been a place where life had a shot. Not little green men, but tiny microbes, the kind that thrive in extreme places here on Earth. One of the most exciting discoveries came when Perseverance analyzed a rock named Jake Matievich. The analysis showed that the rock was volcanic in origin and likely formed in the presence of water. These findings are crucial because they offer clues about whether the planet could have supported life in the past. But the real game changer was the discovery of organic molecules in Martian soil. Organic molecules are the building blocks of life, and while they don't prove life exists, they strongly suggest that the conditions for life were once present. Could Mars have once hosted living organisms? It's an exciting possibility that keeps scientists digging deeper. Of course, the journey wasn't always smooth. Mars wasn't kind to Perseverance's wheels. Sharp rocks tore through them, leaving holes and cracks. Engineers had to get creative, tweaking the way the rover moved, finding less dangerous routes, and keeping it rolling long past its original mission time. Perseverance was built to last just a couple of years, but it kept going strong, outliving expectations and making new discoveries along the way. Before Perseverance even left Earth, NASA ran it through brutal tests. Engineers put it through extreme conditions, making sure every part could handle the worst Mars had to offer. Parachutes were tested under insane speeds, radar systems were flown over Mars like deserts on Earth, and every piece of the rover was checked, double-checked, and checked again. When the time came, all that prep work paid off. Perseverance not only survived, but thrived, paving the way for future missions. Perseverance's mission isn't just about looking for signs of ancient life. It's also about testing technologies that could be crucial for future human missions. Take MOXIE, for example, a clever device that turns Mars's carbon dioxide atmosphere into oxygen. Yes, you heard that right. Perseverance is literally making air on Mars. This is a huge deal because it shows we might not need to haul tons of oxygen from Earth when humans finally set up camp on the red planet. Curiosity rover measured ionizing radiation levels of 76 milligray per year. This level of ionizing radiation is sterilizing for dormant life on the surface of Mars. It varies considerably in habitability depending on its orbital eccentricity and the tilt of its axis. If the surface life has been reanimated as recently as 450,000 years ago, then rovers on Mars could find dormant but still viable life at a depth of 1 meter below the surface, according to an estimate. Even the hardiest cells known could not possibly survive the cosmic radiation near the surface of Mars, since Mars lost its protective magnetosphere and atmosphere. After mapping cosmic radiation levels at various depths on Mars, researchers have concluded that over time, any life within the first several meters of the planet's surface would be killed by lethal doses of cosmic radiation. The team calculated that the cumulative damage to DNA and RNA by cosmic radiation would limit retrieving viable dormant cells on Mars to depths greater than 7.5 meters below the planet's surface. Even the most radiation-tolerant terrestrial bacteria would survive in dormant spore state only 18,000 years at the surface. At 2 meters, the greatest depth at which the ExoMars rover will be capable of reaching, survival time would be 90,000 to 500,000 years, depending on the type of rock. Data collected by the Radiation Assessment Detector RAD instrument on board the Curiosity rover revealed that the absorbed dose measured is 76 milligray per year at the surface, and that ionizing radiation strongly influences chemical compositions and structures, especially for water, salts, and redox-sensitive components such as organic molecules. Regardless of the source of Martian organic compounds, meteoric, geological, or biological, its carbon bonds are susceptible to breaking and reconfiguring with surrounding elements by ionizing charged particle radiation. These improved subsurface radiation estimates give insight into the potential for the preservation of possible organic biosignatures as a function of depth, as well as survival times of possible microbial or bacterial life forms left dormant beneath the surface. The report concludes that the in situ surface measurements in subsurface estimates constrain the preservation window for Martian organic matter following exhumation and exposure to ionizing radiation in the top few meters of the Martian surface. In September 2017, NASA reported radiation levels on the surface of the planet Mars were temporarily doubled and were associated with an aurora 25 times brighter than any observed earlier, due to a major and unexpected solar storm in the middle of the month. But the most exciting aspect of Perseverance's mission is its role in the upcoming Mars Sample Return Project. NASA and the European Space Agency are teaming up to fetch those sealed tubes of Martian rocks and soil. The plan is to send another spacecraft to Mars to grab the samples and bring them back to Earth by the early 2030s. If all goes well, these samples could answer some of the biggest questions we've ever had about Mars. Was it ever alive? What does its geology tell us about the planet's history? And perhaps most importantly, what does this mean for the possibility of life elsewhere in the universe? Perseverance's mission is a testament to human ingenuity and perseverance. It's not just a machine, it's a pioneer. Every time it drills into the ground or zaps a rock with its laser, it's bringing us closer to understanding a world millions of miles away. Even in its early days, it left a mark, literally. When it rolled across the dusty surface, its wheels stamped out the letters JPL in Morse code. Mars may be a harsh and distant world, but through Perseverance's eyes, it's a place of wonder and endless discovery. As the rover continues its journey, it keeps uncovering new mysteries and inspiring us to keep reaching for the stars. The work Perseverance started has made way for a new era of exploration, one that might one day bring humans to Mars. So, is Mars truly a barren wasteland? Or could this footage hint at life? NASA isn't ready to confirm, yet. But one thing's for sure, the red planet still holds many secrets, and thanks to Perseverance, we're closer than ever to uncovering them. Mars has always been that strange neighbor in our solar system, full of surprises that keep scientists scratching their heads. From its bizarre atmospheric events to unexplained geological features, the red planet continues to challenge everything we think we know. Are these questions clues to past life, hidden processes, or something entirely unexpected? One thing's for sure, Mars isn't giving up its answers easily. Do you think Mars could have once hosted life? Share your thoughts, and don't forget to like and subscribe for more updates on humanity's journey to the stars. The mystery is only getting deeper, and the best is yet to come.